Hello, this is my Module 6 inquiry lesson. I struggled a little bit with this lesson. I was pretty frustrated with the sensor itself because it wasn't recording temperature, which I thought would have been perfect for a math classroom and trying to create a line of best fit. I also wanted to try to then do acceleration and movement, but it wasn't really working. I started with a pendulum task, but I was struggling with it. So I tried to do some research on some things and ended up using the light sensor in terms of intensity of a light bulb and was trying to guide the lesson towards the relationship between the intensity of a light bulb and the distance that somebody is away from it. So to start the lesson, I would display a couple of different types of lights in front of the classroom, maybe a tubular light, a frosted light, and a clear light, and have a student come up towards the light and then try to have the class observe what happens when somebody walks away in terms of the intensity of the light bulb, and hopefully they would realize that it feels like the light would be maybe less bright the further they are away from the light. So I would ask students what observations they were able to make when they were in front of the light bulb in relation to when you walked away from it, and they would write this down on their worksheet that is attached on D2L. And maybe to see what students observed, what type of light matters in different locations, and maybe how does the type of light cost impact the purchase price of a light bulb, so in terms of the economy and consumers. So I'm sure that there would be a lot of different research questions that would come up, but in particular, I'm hoping to see what's the relationship between distance and light intensity, and hopefully one group would explore this question and would be able to come up with their own question and then their own procedures as they go. So the note sheet that I have on D2L is pretty open-ended in terms of what students would be able to explore and what they would end up hypothesizing. So some background information that they would need is to know how to measure light intensity, and it's measured in lumens per meter squared, which is what the LUX stood for on the sensor probe. Students would then have to hypothesize and graphically display their thoughts. So this is what I thought maybe would happen. I predict that the further away you get from the light, the density will decrease. And maybe is this linear equation or is it different? Experiment, students would need to figure out what materials and what data they were collecting. So you can find this also on D2L. These were my answers based off of what I thought would happen and how I ended up creating the procedure myself and what materials that I would need. And there's some pictures later on. And then the investigation process, students would have to collect data by creating a table and then graphically display their data. And this was what happened with mine. And as you can see, this is an exponential function that is decreasing dramatically. It's actually an inverse equation that hopefully students can start to relate to a function in math and relate to some math standards. Students would then have to analyze and conclude what happened and how could you maybe relate it to a mathematical equation or function, especially if they were in high school level math classes. And they would write down some observations and ask maybe how this could relate to any career. And it actually does relate in terms of science, possibly to NASA as well. And there's a link at the end of the website for a reference. You can figure out the distance something might be based off of the intensity of the light. And also you could predict the intensity of the light based off of the distance. So here's a little bit of me recording. I first started out with a night light that wasn't grabbing a lot of information. But then this is the light in front of the bulb and then further away. It actually looks a little bit brighter in the picture, but when you're up close, it's much brighter when you're up close. And then this is the contraption that I built. This is also on the side here what the sensor looks like and how it was reading when it plateaus. That means that's what it's like at that specific centimeter. So I did 5 centimeters, 10 centimeters, and I kept going back. And it dropped significantly. Students would then have to reflect on maybe what were the positives and negatives on it and find a career to apply the knowledge. And overall, I guided this as a guided inquiry because it's not completely up to the students for a question. It's hoping that the students create a question based off of what they observed from the beginning lesson, but it will be guided a little bit from the teacher, but it is open-ended for the students as well to come up with their own experiments, and it could lead to some other questions too. There on D2L, you can find my worksheet and also an answer key that I did myself on the project.